In this video, we are beginning the next chapter in our course, which is going to be Chapter 4. Chapter 4 starts incorporating aspects of rotations into systems. Now, we're going to approach some of these sections a little out of order compared to the book, but it should be fine. So we're going to start with sections 4.1 and 4.4. They kind of go hand in hand together. In fact, I'm not really sure why they're not in order as 4.1 and 4.2, but we're utilizing 4.1 and 4.4 right now, and then in later videos we're gonna return back to sections 4.2 and 4.3 in the textbook. So what we're talking about today in this video is two-dimensional moments. Now the question is, what is a moment? Well, there are several types of moments. Okay, so we're gonna say types of quote-unquote moments. All right. One type of moment is called a torque moment. Okay. Now, in a physics course, you may have only called this torque. The short name for it is just a torque or a torsion, but the full name is actually torque moment. Okay. Another type of moment is called a bending moment. Okay. And then we have a third type of moment called a couple moment. And then a fourth type of moment called moment of inertia. So in this part of the course, we are really going to be focusing on bending moments and couple moments, and we are going to spend a little bit of time on torque moments as well. But again, the focus is going to be on bending and couple moments, okay? So what is a moment? So a moment, this thing that we call moment, is a tendency of rotation. Okay, something called a tendency of rotation. So basically, when we say, when we use the word moment in terms of engineering and statics, we're referring to something that is causing a system to want to rotate somehow. And more specifically, that's when we would look into the specific definitions of a torque moment, a bending moment, a couple moment, or a moment of inertia. Again, we're going to talk about moment of inertia in much later in the course. We're really just going to be talking about these three right now: torque, bending, couple moments. Okay, so the question is, how do we handle these kinds of phenomenon? So the units for moment are force times perpendicular distance, or just force times length. Okay, so that's units like, for example, pound feet, or maybe pound inches, or maybe kip feet, or Newton meters, etc. Okay, so again, it's force multiplied by length. Now, I kind of hinted at this a second ago. What is this length that we're referring to? Well, the length is what's called a perpendicular distance. Okay, so the length is a perpendicular distance between the force and a point of interest. Okay, so that's it in general. Now, the next question is, what distinguishes between this thing called a torque moment versus a bending moment versus a couple moment? Okay, and that's what we're gonna end up talking about in the following videos. Okay, so a couple more items in this video, and then we're going to move on to looking at each one of these types of moments more clearly. All right, so again, a moment is going to be equal to a force times a perpendicular distance. Okay, that's a shorthand of saying that. Also, the right hand rule is valid. Okay, so if you remember maybe from a physics course, what the right hand rule is. All right, so basically what you do is you take your right hand and you curl your fingers into the palm of your hand. Okay, and the curl of your fingers is supposed to match the direction of rotation of whatever your system is dealing with. And then the direction that your thumb is pointing is considered positive rotation. All right. So I suggest you read section 4.1 of the text for a complete explanation. Okay. So we're going to start with two-dimensional systems, okay? So for 2D rotations, which are planar, remember that planar, we typically call counterclockwise positive, okay? So we say rotations that are going counterclockwise are going to be considered positive rotations, and that matches pretty nicely our knowledge from trigonometry and the unit circle. In addition, a resultant moment may be computed as the sum of the moments about a particular point, okay? So, for example, we can say a resultant moment equals the sum, resultant moment about a point O is equal to the sum of all the moments about point O, okay? And another thing to keep in mind, notice how I drew this. Moments are vectors, right? They can have a magnitude, and of course they can have a direction. I talked about how directionality of moment counterclockwise is typically positive, okay? So one other piece of this is a moment axis is perpendicular to the plane that contains the force and moment arm. Now, what do I mean by moment arm? The moment arm, if I say moment arm, I'm referring to whatever the perpendicular distance is that I'm interested in, okay? So I know this was a lot of vocabulary, a lot of terminology. Maybe, rewatch this video a little bit and take all these notes down. And in the following videos, we're going to get into some numerical examples.